So one of my favorite things about woodworking is that I just get to hit stuff. I'm not going to make some snappy joke or something, that's it. I love to hit things. Since we're talking about woodworking, I bet you'd expect me to talk about this. The old faithful carpenter's hammer. It's got a claw and a striking face. And I use these, but really only for household stuff like repairs. I don't think I've ever used one for woodworking. Here are all the things that I use more often. Large ball-peen hammer. Small tack hammer. Dead blow hammer. Rubber mallet. Double-sided rubber mallet. 2-pound hand sledge. Small ball-peen hammer. Rawhide auto body hammer. Now, these are all really good hammers, and at some point you should probably pick up most of them. The ball-peen hammer and the tack hammer get the most use in my shop. But even though all of these are good, they aren't my favorite. Even though I own lots of hammers, I do almost all of my woodworking with old-fashioned wooden mallets. Now, most of the time, you're using mallets to hit chisels. And these days, a lot of chisels come with plastic handles, and you really can beat on them all day long with a hammer without damaging them. But you might not want to. The thing that's great about wooden mallets, especially when you're using them with wooden-handled chisels, is that as you strike the chisel handle, the mallet compresses a little bit, and then it expands and delivers that energy into the chisel handle, which also compresses and expands. That way you have an extremely efficient transference of force and very little spring back that you have to absorb in your elbow. Even though mallets like this seem old-fashioned, they're actually very efficient and ergonomic. Out of the three, I like this one the best. It's a traditional joiner's mallet, and I made it myself. It wasn't very difficult, and all it cost me was a few wood scraps, but it wasn't exactly a beginner's project either. If you're just starting out with hand tools, this might be biting off a little bit more than you can chew. Instead, it would be really great to have one of these carver's mallets or one of these traditional round mallets. The traditional carver's mallet is good when you want to tap things gently or hit things from different angles. And the traditional round mallet is also really useful. Large and heavy enough for when you really need to hit something harder. Now, of course, you can make both of these mallets really quickly using a lathe. But of course, if you're watching this channel, you probably don't have a lathe. And that's okay. You don't need one. If you have a couple of hours, you can make both of these mallets in your own shop for about $1. All you need is a rolling pin. I got this one at a thrift shop, and I think it cost me 50 cents. Rolling pins are actually perfect for this. The size is good, they're relatively heavy, and they're made out of maple, which is the exact same sort of wood that you would make a mallet out of anyway. It's close-grained, dense, and won't split. Aside from your rolling pin, you'll need a couple different sizes of dowel. Oak or maple is best, but you can really use whatever you have sitting around. You're also going to need some round dowel-shaped piece of metal. This is the stem from a large bolt that I cut the head off, but you could use anything you have sitting around as long as it's iron or steel. A piece of rebar would even work fine. And you'll need some scraps of hardwood to fill in holes and make a handle out of. I've got exactly 12 inches of rolling pin, so I'm going to use about 6 inches for my large turned mallet and maybe 2 or 3 inches for the head of my carving mallet. Cutting large round pieces like this rolling pin can be difficult and dangerous. Power saws want to spin them or grab them out of your hand and throw them across the room. So I'm using my miter box. It makes a nice clean cut, and I've still got all 10 fingers. Now for the handle, I've taken a piece of oak. It's about 12 inches long, 1.5 inches wide, and roughly 1 inch thick. This piece isn't square, so I'm just putting it in the vise and planing off the rough side. I stop every couple of minutes and check the end to make sure it looks like it's getting square, and then after I've got it pretty close by eye, I stop and check it with a little machinist square. Everything is square and level, so now I'm done, and I can check it for width. I'm going to use a 3/4 inch Forstner bit to make the mortise in the head of my mallet, so I need the handle to be exactly 3/4 of an inch. It's over right now, so I plane it down a little bit more and check it again. Now it's just about perfect, so I'm going to stop and try to make the handle a little bit more comfortable. I want it to be tapered, so the first thing I'm going to do is mark the bottom for 1 1/8 in width. Then I mark the width of the mallet, which is 2.5 inches. I don't want that part to be tapered, so I leave it square. I connect the bottom of where the head is going to sit to the 1 1/8 line I made in the bottom, and that gives me my taper. I just plane that off in the vise, but you could use a bandsaw or a table saw with a tapering jig if you have one. There are no brownie points for doing this the hard way. Once it's tapered, it's starting to feel like a mallet, but it's still got really uncomfortable edges, and now's a good time to take care of those. I've got my block plane set up for a relatively fine cut, and I chamfer the edges, changing the angle of the plane as I go so it's not just 90 degrees, but it's actually rounded and more comfortable. Now, it's better, but it could still use more work, so I make a mark about halfway down the handle section. I just eyeball it, then put the handle into the vise and work up from either direction towards that mark with a spoke shave. What I'm aiming for here is to have a scallop that's thick in the middle and narrows at either edge. That's going to make it easy for my hand to grab it in exactly the right spot. There's no science to this, just keep working on it until it feels right. Work up towards that middle mark from each section, and you might have to flip it around a few times because you'll get confused. I just did. Now I've made a center mark on my mallet, and I'm going to draw a center line on my mallet head. It's pretty easy to do freehand. Just line it up with the edge of the head and draw a line. You'll probably get it right on the first shot. Then you also want the center point, so measure in from either end to get that. Then you can line up the center point that you made on your mallet, and now the mortise is laid out. You just need to know where the ends are, because you're going to be drilling out most of the mortise. So now I've got my Forstner bit set up so the edge is where the edge of the mortise is going to be, and the point of the bit is on that center line I just drew. Now I can flip on the drill and start doing the work. Now I'm using a drill press here, but you can obviously do this with a hand drill or even a brace and bit if that's what you've got. One of the downsides to the drill press is you might forget to clear the chips like I did and get the bit jammed in there. So I took it out and cleared the chips, and now I'm going to continue my mortise. You'll notice that I'm only going a little bit each time now and clearing the chips. I hate getting the bit stuck because it makes me look like a giant idiot on camera, and nobody likes that very much. Once I get to the end, I line up the Forstner bit really carefully with the other edge and drill down slowly, making sure to clear the chips again like I've been doing. Now the great thing about Forstner bits is that once you're done drilling the main holes, you can go back and drill out the waste because they don't need to be centered on whatever they're drilling. Now I've got most of the waste for the mortise taken out, and I'm just going to take a chisel, put it almost on the sideline, not quite, and tap it down with a mallet. I'm keeping it exactly perpendicular and then levering forward to clear the waste. And I'm just going to move forward through the mortise that way, clearing out the waste with my chisel straight up and down and perpendicular. Now I've got a hole that's pretty good, although one of the Forstner bits drifted over a little bit on one side. We'll just make that the bottom of the mallet head, and nobody will see it. The handle won't go in exactly, and so now's a good time to do a little bit of paring. I'm just gently working out the waste on either side. I do it from one end of the mallet, and then I flip it around and do it from the other end so it won't break out. Now I try to fit in the mallet handle, and it still doesn't go in as far as I want to. Looking at it, I see there's a gap on either side, but it's very tight on the ends, so I need to take a little bit more material off there. Off camera, I just pare that off really quickly. And what I'm left with is a mortise that fits much better. When the handle's only sticking out about 1 inch, you can tap it down until it's seated. Only a 1/2 inch or maybe 3/4 of an inch are left. So now we've got something that looks and feels an awful lot like a genuine woodworking mallet. There's only 2 problems. First, it's too light. And second, well, it has giant holes in either end. But don't worry, we're going to fix both those problems. First thing we're going to do is deal with the weight. Grab your piece of metal, bolt, rebar, whatever, and cut a couple of slugs about 3/4 of an inch long. You can use a hacksaw or the cutoff wheel on an angle grinder. Me, I own a metal cutting bandsaw, so I'm going to go use that. Hold on a second. Now I've got 2 steel slugs, and they're 3/4 of an inch long by about 5/8 of an inch in diameter. I've also taken the head of my mallet over to the drill press and drilled either end out to 5/8 of an inch. That means my slugs fit right in, snug but not too tight. They're pretty easy to get in and out. Putting these in is going to solve the weight problem and give me the heft I need to really whack on things. Now, the other thing I need to do is fix the holes in the end, and that's what my piece of scrap dowel is for. This dowel is about 3/4 of an inch thick, so I'm going to head over to the drill press and drill out the ends of the mallet to 3/4 of an inch, and then cut two 1-inch sections off this piece of dowel. Now, if you either don't have good hardwood dowel or you're running out of drill bits in the sizes that you need, no problem. Go ahead and take a square piece of stock, put it over this opening, trace around it, and then just chisel out a small square recess. Like our mortise for the top, it doesn't need to be perfect, you just need to be able to get your piece of hardwood scrap in there, and then we're going to glue everything into place. Here I'm going to do the assembly of the mallet. It's pretty simple. I'm using 5-minute epoxy, which I stir up on an old piece of sandpaper. Once the epoxy is well mixed, I'm going to add a little bit of sawdust that I collected from underneath my bandsaw. The dust is going to thicken the epoxy, it's going to make it blend in better, and it's going to allow us to use less glue and fill the gaps more efficiently. I also quickly grab a drift, which I'm going to use to knock my metal slugs in. They might be a little tough to get into the holes once the glue is on them. And it is, so I've got to pound them in a little bit to get them seated. Then I cover the pieces of hardwood dowel with glue and tap those in with a carver's mallet. Then I take the glue and spread it around to fill all the gaps. I also do that around the handle so that none of the gaps in the mortise show once it's dry. So here's my completed mallet. To get it to this stage, I cut off the plugs that were sticking off of the faces. I used a fine-tooth back saw, but you can use any sharp saw you have sitting around, or a bandsaw. That'll work great too. After the sides were cut flush, I put it in the vise and used a block plane to further flatten and true up the faces of the mallet so they'd strike really evenly. Then I used a combination of sandpaper and a card scraper to get rid of all of the old dried epoxy and make sure all the surfaces were smooth and clean to the touch. Now the mallet I just made is actually better than the vintage turned mallet in one key respect. Because we gave this one a rectangular handle, as soon as you grab it, it automatically registers in the hand, perpendicular to the direction of force. It's always facing the way that you want it to go. This mallet, because it's got a round, turned handle, if you grab it without looking, you can't tell which way it's facing, and it's easy to pick it up and try to hit a chisel, only to find that you have it on a diagonal or some sort of awkward angle. Also, while you're working, it can slowly drift away to an angle that's not optimal while you're hitting. This mallet can't do that, so strangely, it's actually better than the traditional one. And once you've finished making a mallet like this, it's going to be really easy to use the same materials and techniques to make a carver's mallet, like one of these. I started making the carver's mallet by taking the piece of rolling pin that I had left over and cutting about 1 inch off of it. That makes the chunk that I have left really similar to one of the mallets that I actually bought. This little piece that I have here is going to be important for a later step, so don't throw it away. Over at the drill press, I've got the rolling pin clamped in with a couple pieces of cardboard, just to pad it and keep it from getting dented. I'm drilling out 3/4 of an inch to about 1 inch deep, and that's going to let me put the handle in. Then I flip it around and drill out 5/8, about 2 inches deep. That's going to let me get my metal slug in. This mallet only has 4 pieces, and I've got them laid out here. I've got the main part of the mallet, the bottom part, which I made out of that tiny piece of rolling pin, the dowel, which is going to be the handle, and my metal slug. This slug is about 2 inches long because I've got the space and I want this mallet to be heavy and deliver plenty of power every time I hit a chisel with it. I'm doing the same thing, just mixing in a little bit of sawdust with the epoxy. When I've got enough and it's as thick as I want, I knock off the excess. Then I roll the pieces in the epoxy and stick them in. I use my finger to spread the glue around and a paper towel to get rid of the excess. Now when I'm putting in the dowel, I stick it in the glue and then I twist it into the head of the mallet. That distributes the glue more evenly and makes sure I'm not going to have a dry spot. I do the same thing with this bottom piece here, and then the whole thing is wiped down with the paper towel and it's ready to be clamped, and I can leave it that way, usually for about 24 hours. Once the mallet comes out of the clamps, you need to shape it a little bit. These sharp edges are no good against the hand, and they make the tool uncomfortable. So you can clamp it in a vise or just use C-clamps against a workbench, whatever works. And then you can shape it with a file or a rasp or even a piece of sandpaper glued to a stick. Here I'm using a Nicholson Super Shear, the finest wood shaping device ever invented. I hope to do a video about them in the future. Once that's done, I work on this bottom part here, the stop at the lower part of the handle. It's really important that this feels good because it's going to touch your hand pretty much the entire time you're using the tool. The only thing left to do now is test the mallets. Here's the round mallet, and you can see that I'm using it to take off large pieces of wood. You can use it aggressively or gently, and it stands up to whatever treatment you need. Here's the carver's mallet, and it's good for working things more gently and hitting things from different angles and with a little bit more finesse. Now, I don't actually know anything about carving, so I'm pretty much just faking it here, but you can see that it's not very difficult for me to take little chips of wood out and make recesses of any size or shape that I need. So now we've made a carver's mallet and a chisel mallet, and it's only cost us $1 or $2 in materials and a few hours of shop time. Now, these tools might not look like much, but they don't require any compromises from the user either. They're solid enough and heavy enough to do real work, and they should last for years. The longer you do woodwork, the more likely it is that you're either going to find vintage ones that you can buy at a good price, or acquire enough skills to make your own. In the meantime, these two mallets are going to take care of everything you really need in the workshop. On top of the other tools we've already bought, we still haven't even spent $40, so we have a lot of money left to use to fill our toolbox for only $100. Catch up with me next week, and we'll talk more about cheap tools and ways to make them. Thanks for watching.